Okay, ji. So January 2020 paper, Unit 4. This question is about four organic compounds, each with five carbon atoms, but different functional groups. Okay. So the first compound is going to have acyl chloride. This is C double bond OCl, acyl chloride. And this one is aldehyde. This one is ketone. Am I supposed to write acyl chloride? Then this is aldehyde. This is ketone. This is amide. They are saying which of these, when mixed with water, produces the solution with the lowest pH. You know, acyl chloride is having this partial positive carbon, partial negative chlorine, and partial negative oxygen, which makes this carbon more partial positive. So any of the nucleophile can attack on this carbon and it can easily displace this chlorine. Okay, so you know when you are going to dissolve mix aldehyde into the water, it's not going to produce the acidic solution. It's not going to produce any acidic solution. It's not going to produce any acidic solution. Remember, okay? So we have one and only thing, that is acyl chloride. When we were doing the theoretical portion of this acyl chloride, so we discussed that acyl chloride can be hydrolyzed easily due to the very strong partial positive carbon over there. So that's why I would say that compound A is the only compound which can give you the lowest pH, because it's going to form carboxylic acid after the displacement with the OH minus ion. And OH minus ion is coming from what? Is coming from water. Is coming from water. Okay. Then which of these reacts with ethylamine to form an N-substituted amide? You know what is N-substituted amide? So, like if you can see which of these reacts with ethylamine? You know, ethylamine is a base. Ethylamine is a base. Remember, it can only react with acid. Like, or I can say that it can only react with the most partial positive center. And of course, only we have acyl chloride that is going to have a stronger partial positive charge on this carbon atom. On this carbon atom, this is strong partial positive. This is a strong partial negative. This is a strong partial negative. Remember, so so the lone pair on this nitrogen can easily attack on this positive center, that is carbon. Okay, so I would write compound 1 again. I would write compound 1 again. So it's gonna produce this product. Okay, the thing is that in this question, that amines are going to react with the stronger partial positive center, that is your acyl chloride. Okay, and they do not react with amide. This is important concept. Amines are not going to react with amide. So totally compound 4 is incorrect. This is amide. This is amide, remember. And also aldehydes do not react with the amine. This is also an important concept. Okay. Like I can say that like aldehydes are also having the partial positive center, but you know it's not gonna produce N substituted amide. It's not gonna produce. Let me tell you what is N substituted amide. I'm going to react with this one. So let's suppose. Uh, okay. Yeah. So it's amine CH3 CH2 and then NH2, one lone pair. So I'm going to form the product over there, okay? One, two, three, four, five, six. This is chlorine. This is the one, this one. Okay, N substituted amide. So this is amide, okay? This is amide. That's it. Which of these reacts with iodine and sodium hydroxide in solution to produce a pale yellow precipitate? This is iodoform test. This is iodoform test. So I told you that iodoform test means that um, it can only give you the positive result whenever you have methyl ketone. Whenever you have methyl ketone. Whenever you have methyl ketone. Okay. So so let's see. We have these compounds. It doesn't have any methyl ketone. It doesn't have any methyl ketone. It has a methyl ketone. That is CH3C double bond O. That is CH3C double bond O. Remember, that is CH3C double bond O. Okay. So I would write that. I would write that. Which what is the compound? Like three. Like three. So compound three is gonna give us the positive result for with the iodoform. It's going to give us a pale yellow precipitate, and this would be CHI3. It's iodoform precipitate. Okay. Which of these molecules can rotate the plane of plane polarized light? Of course, it must have a chiral center. It must have a chiral center. It must have a chiral center. Remember. So chiral means that four different groups attached with the central carbon atom. Like you can see what's the structure for option A. It would be NH2 and then CH2 CH2COOH. This and this, they are the same group. This and this, they are the same group, okay? And 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 this one, okay, and this one CH2OH, CH2, and then C double bond OOH. There is no any chiral carbon. Same group, same group. This is not a chiral carbon. Let's check C. So C is gonna be HCl, H, C, then CH3, then it has Cl, then C double OH. Yeah, of course it has a chiral center. That is this. Okay, different, 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 then different. So four different groups attached. Four different groups attached. So this is C. If it has a chiral center, it's going to rotate the plane of plane polarized light. Okay. Then question number three. A polymer is prepared by the reaction between hexane dioil chloride. You know what is this? One, two, three, four, five, six. Dioil chloride. Dioil chloride. And hexane. One, two, three, four, five, six. And hexane 1,6 diamine. 1,6 diamine. Okay, they would be reacting with each other. Of course, water would be released. So this is not an addition polymer. 100%. It's a condensation polymerization. and the linkage that would be formed as a result of this would be called amide linkage. Amide linkage, because there is a nitrogen, remember. Then question 4 says the compound this reacts with excess sodium hydroxide solution. What is the organic product formed in the reaction? What is the organic product formed in the reaction? So we have to react with the sodium hydroxide solution. Since you know that, what is this? First of all, you know what is this? This is going to be C double bond OH. Then I have carbon. Then I have carbon. Then C double bond O. Then OH. Okay. Of course, it's an acid. It's going to react with NaOH. It's going to react with NaOH, and it's going to produce a salt. It's going to produce a salt. So let me tell you what would be the salt. Let me tell you what would be the salt. That's gonna be sodium. Sodium and sodium. So what's the answer? 100% A is correct. There is no sodium. There is sodium, but what is OH? What is OH? There is sodium, but what is this? This is aldehyde. No, option A is correct because only the acid base reaction is going to take place between this acid and a base. There is only acid base reaction. There is only acid base reaction. That's it. Okay. And then question 5. Which diagram shows the mechanism for the second order reaction between 1-bromoethane and potassium hydroxide in an aqueous solution? Okay, second order reaction between 1-bromoethane and potassium hydroxide. 1-bromo means that it would be primary halogenoalkane. Okay, so which diagram is correct? Which diagram is correct? So then what we have to do? Diagram 1, diagram 2, diagram 3, diagram 4. Okay, you can see that. You can see that like let's check option A. Like I'm talking about diagram 1. You know, it's what? It's a primary halogenoalkane. Okay, it's a primary halogenoalkane. So it's going to give what? Which diagram shows the mechanism for the second order reaction between 1-bromoethane and potassium hydroxide? Okay. So then what about diagram 2? What about the diagram 2? This arrow is incorrect. Always the negative species is going to attack. Remember, always. This is fixed. This is fixed. Okay. And you can see the diagram 3. You can see the diagram 3. It's 1-bromo. This reaction should take place in one step. Remember, this reaction should take place in one step. It's SN2 reaction. So what is this? Why it's going to take place in two steps? First of all, the bond is going to break down, then this is going to attack on this positive center. What is this? This is incorrect. Option 1 is incorrect. Diagram 1 is incorrect. Why? It's going to form carbocation. If you remember, we discussed two types of reaction, SN1 and SN2 reaction. SN1 occurs in two steps. SN2 occurs in one step. So if this is primary, so why this is going to be in two steps? This is wrong. This is wrong due to this. This is correct. This is correct because whenever you have primary halogenoalkane, it's not going to produce any carbocation rather than this intermediate. Rather than this intermediate, remember. And again, option D is incorrect. Diagram 4 is incorrect. What is this? Why this positive is going to attack? only always the partial positive, like always the negative species would attack on the partial positive center or a positive center. Remember, this is important. Okay, so diagram 3 is correct, like C option is correct. Okay, if you are having any sort of confusion, so do let me know, right? Otherwise it would be a big problem for you. And then they are saying in the next question, question number 6, which of these reacts directly with ethanoic acid to form ethanoyl chloride? Ethanoic acid is an acid. Ethanoic acid is an acid, okay? So they are saying which reacts directly to form ethanoyl chloride. You know what is ethanoyl chloride? Like that, like that, like this one. Okay, it's gonna produce this one. So of course, I told you when we were discussing this one, I need any compound containing chlorine. It should be reactive so that it can react with the carboxylic acid, ethanoic acid. So it's one and only option, that is PCl5. I told you the three options: PCl5, PCl3, PCl3, SOCl2. We have three reagents that can react with this ethanoic acid, this carboxylic acid, to produce ethanoyl chloride. Like OH would be substituted by the Cl. OH would be substituted by the Cl. So that's why option D is correct. Okay. Then question number 7. Zafir, what do you think? What should be the answer for question number 7? It's easy. It's very easy. Mhm.
B. Option B, sir.
Option B, yep. Option B, because you know why? Because liquid is changing into gas. So the particles becomes more disordered. When the particle become more disordered means the entropy would be higher. So option B is correct. Arkam, can you tell me what's the answer for question 8?
Option D, sir.
D for doctor or B for ball?
Doctor.
Doctor. Okay. Equal amounts of Wx are mixed and allowed to reach equilibrium. The value of the equilibrium constant is Kc, that is equal to 4.85. At equilibrium, the mixture will contain almost all Y and Z. The value is 4.85. Okay. Of course, this is at equilibrium. So, of course, at equilibrium, all the species are present. So, means A and B is incorrect. 100% A and B is incorrect. We have to decide between C and D. They are saying in C, W, X, Y, and Z, but there is a less Y and Z than W and X. Why? Man, your Kc is positive. Your Kc is greater than 0, means that the reaction would be converting into the product side. It's going to shift towards the right. Okay, it's gonna shift towards the right. So when Kc is less than 1, so the reaction will move backward. This is important point for this question. When Kc is less than 1, so the reaction moves backward. And when Kc is equal to greater than 1, so the reaction moves forward. So the reaction move forward, simple. Okay, so that's why option D for doctor is correct, right? What does X represent on the diagram? Sum of enthalpy changes of hydration of the gaseous ions. Sum of the enthalpy changes of the gaseous ions. X is the total. X is the total. Like Like let's suppose if this is 3 centimeter, if this is 2 centimeter, this would be 5 centimeter. It's the sum of these two values, of course. So means option A is correct. 100% option A is correct. Okay. It's not the formation of lithium, it's the formation. It's not the formation. Remember, in C, it's not the solution. It's not the solution. Okay. It's hydration. It's hydration. Remember. And lattice energy. Oh, okay. It's not possible that this is lattice energy, because if you remember, like we used to discuss different things in lattice energies. Okay, this is not a lattice energy. So sum of enthalpy changes of hydration of the gaseous ions. How are 20 cm cube of 0.05 mole per dm cube H2SO4 and 20 cm cube of alike? Both solutions have the same pH. How can you say? How can you say? You have to solve it. You have to solve it. You have to find out the moles. You have to find out the moles. So the mole of H2SO4 would be equal to 20 divided by 1000 multiplied by 0.05. Then I'm going to solve it. Mole is equal to 20 over 1000 multiplied by zero point 0.1. Can you tell me the answer for the first one?
1 into 10 power minus 3.
1 into
10 to the power of minus 3.
and another one.
2 into 10 power minus 3.
Oh, okay. So this would be multiplying by 2, because H2SO4 is going to give you the 2H positive ions, and it's gonna give you only 1H positive ion. So of course the value would be the same. The value would be the same, like the concentration of H positive ion would be the same. Remember, okay? So how are alike? Both solutions have the same pH. CH3COOH is a weak acid. Is a weak acid. It doesn't ionize easily. It's a weak acid. If this is a weak acid, so they can never have the same pH. Remember, B option, have the same total concentration of ions. Have the same total concentration of ions. No, they have different concentration of ions. Remember, because they're not saying like the H plus ion. They are saying total concentration. We have two ions, man. So this is totally different, okay? And I want to say that CH3 COOH gonna give you only two ions. First of all, Chiku and H positive. And it's gonna give you three ions, two H positive ion and one SO4 2 minus. To total three, it's total two. So how can I say have the same total concentration of ions? B is incorrect. Incorrect. Have the same total concentration of negative ions? No, 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 no. They are different. They are different. Remember, okay? They are different. And require this one. Require 20 centimeter cube of zero point 0.1 mole per decimeter cube sodium hydroxide for the complete reaction. For the complete reaction. So, 20 divided by 1000 multiplied by zero point 0.1. So we got 2 exponent minus 3. So means that same moles, same moles, same moles. Yeah, it can neutralize this sulfuric acid. It can neutralize this methanoic acid, ethanoic acid. Yeah, option D for doctor is correct. Quite tricky question, so you have to take care it. Then it's from titration curve. It's from titration curve. Which two solutions both of concentration zero point 0.1 mole per decimeter cube, zero point 0.1 mole per decimeter cube have been used to produce this titration curve? Have been produced for this titration curve. So then what we would be doing about that? So I would say that HCl and KOH, first of all, you have to see from where the graph is going to start. From where the graph is going to start. That's an important point. Remember, the graph is starting in the mid. It may be 4 pH. Remember, it may be 3 pH. Means that it's not a strong acid. It's not a strong acid. Remember, this is incorrect. This is incorrect. So it may be B, it may be C, because this pH is gonna show that it's a weak acid. It's a weak acid. So it may be A, oh sorry, it may be B, it may be C. Okay, it may be B because this is weak acid, this is weak acid. Then I have to see where the graph is ending. It's ending on this pH. Oh, this is a strong pH. So there should be strong base. There should be strong base. So that's why option B for Paul is correct. Okay. Then a solution of sodium hydroxide of concentration 0.008 mole per decimeter cube has a pH between this. What do you think about that? Mhm. Mhm. What's the answer?
C, sir.
Uh, uh, so pH is equal to 0. pH is equal to negative log of 0.0080. Then, of course, this is a strong base. So we would be having a pH. Then what I would be doing, pH plus pOH is equal to 14. After getting the pOH, then I would be subtracting it from the value that I would be having from the 14. Then I would be getting my final pH. So you are saying it should be C. So of course you would be getting an answer between 11 and 13. So they have given a range. That's a good sign for you. They are not going to be specific. They are not going to be specific. Otherwise it would be very difficult for you, remember. And okay. See this one. See this one. A student carried out an experiment to determine the equilibrium constant for the reaction to form ethyl ethanoate from ethanol and ethanoic acid. Different amounts of each substance were added to a flask, each containing 2 centimeter cube of 1 mole per dm cube hydrochloric acid. The flasks were then stoppered and left for a week to reach equilibrium. Each mixture was then titrated with 1 mole per dm cube sodium hydroxide. In which flask was the equilibrium approached? From the right hand side, from the right hand side of the equation. So you have four conical flasks. You have four conical flasks. Okay. So what do you think about that?
Answer is 1 and 4, sir.
Why? Why one and four?
0 and 0 for volume for the reactants.
Okay. And then in four, the same thing?
Sir, the
Why not?
reactants are given.
Why not D for doctor? Flask two and three.
In flask 2, we have volume added in of reactants.
Yep. That's why. So means that 1 and 4 means that 1 and 4 1 and 4 1 and 4 means that this is 2, this is 2, this is 3. Oh, this is this is 2, this is 3, this is 3, and this is 0, this is 0 0 and 0. So that's why 1 and 4 option is correct. Correct. Which of these statements explains why it is possible to titrate the reaction mixture directly to find the equilibrium concentration? Which of these statements explains why it is possible to titrate the reaction mixture directly to find the equilibrium concentration? So you know that in A, the equilibrium reaction is slow. In option B, the sodium hydroxide quickly hydrolyzes the ester. All the reactant concentrations remain constant during the titration. So a buffer solution forms in the reaction. So you know, when the reaction is slow, when the reaction is slow, so you can titrate the reaction mixture directly to find the equilibrium concentrations. You know, of course, you have to find out the concentration at equilibrium. So you can do titration because titration is the process in which you can find out the concentration of unknown substance by using a known substance. That's why this is only possible when the reaction is slower. This is only possible when the reaction, if you remember when we were discussing kinetics, I told you that in kinetics, we can only measure order of reaction when the reaction is slower. We cannot calculate, we cannot find the order of reaction of you can say fast reaction impossible. So of course when the equilibrium reaction is slow, so we can, it is possible to titrate the reaction mixture directly to find the equilibrium concentration. That's it. A reactant Q is converted into two products. Okay, which of these graphs shows that this reaction is first order with respect to Q? You know, I have shown multiple graphs. I have shown to you multiple graphs, concentration versus time, rate versus concentration, we have discussed these graphs. You know, what is first order reaction? First order means that if the concentration is doubled, so the rate is doubled. This is called first order. Remember, when the concentration of a reaction is doubled, so the rate of reaction would be doubled. Okay. So if you can see this one in this line, that when the concentration increases, so the rate increases. When the concentration increases, so the rate increases. Okay. So that's why graph 3 is correct. So that's why graph 3 is correct. Okay. So option C. Option C, very simple. Yeah, see this one. Question number 15. Yes.
Is it option D, sir?
D for doctor, right?
Yeah.
So they are saying nitrogen monoxide is the second order when the concentration of nitrogen monoxide doubles and the concentration of oxygen quadruples, the rate increases by a factor of 8. By a factor of 8. Yeah, this statement is not correct. Exactly. Okay. Because when you would be increasing the concentration of NO by 2, so it would be 2 into 2, that would be 4. And you are going to increase the concentration of oxygen quadruples. Okay. Quad means what? Quad means what? 4 times? Yeah? No? 4 times, right?
Yes, sir.
So that would be 4, 16, not 8. So that's why option D is not correct. What are the units of the rate constant for the reaction? So the units for the rate constant would be K is equal to rate over x to the power 3. So mole per decimeter cube per second divided by, I'm going to apply power 3, mole cube decimeter minus 9, and so I would be canceling just like that, mole minus 2, dm plus 6, and then s minus 1. So what's the answer? dm plus 6, oh no, dm would be um,
DM6 is there. Option D.
option D for doctor, right? Yep, good. An experiment was carried out using 1.10 exponent minus 2 mole per dm cube of oxygen and some nitrogen monoxide. The numerical value of the initial rate and the rate constant were this. What was the initial concentration in mole per decimeter cube of the nitrogen monoxide used in this experiment? Used in this experiment. So how can you calculate this one? Of course, you would be putting that data into this equation. Okay, rate is given to you, rate constant is given to you. So you can calculate the value for X, like I'm talking about the concentration of nitrogen monoxide. Okay, so you can solve it very easily. Rate is equal to K into the concentration of like NO to the power 1 NO2. Okay, so this is the, no, this, it's not 0, it's not 0. It's 2 and 1, I think so. It's 2 and 1. Yep. So after putting the value, you can find out the value for the initial concentration of NO very easily. This would be unknown. This would be X basically. Okay. So what's the answer?
So what is answer for part A?
Okay. The
No,
compound
sir.
ethyl
The
3,
question part.
sorry,
Question 15 part A answer.
question 15 part A answer.
D. Okay.
It's D or A. It's very easy. It's very easy. So I would be putting the values just like that. Rate is 1.7. This one, like that. So then you can solve it and then you will be getting the answer accordingly. Okay, got it?
Yes, sir.
Okay.
So I got
Uh-huh.
0.013.
Means answer A
Very,
is correct, right?
yeah.
Nice. Solution proton NMR spectrum of this compound. Okay, 3 ethyl 3 oxobutanoate. Oh my god, okay. Identify which groups of hydrogen atoms are responsible for each peak in the spectrum by adding the labels W, X, Y, and Z to the appropriate parts of this displayed formula to match the letters on the spectrum. Okay, so the neighbor of this CH3 is CH2. So I would say that I would be getting n plus 1 rule means 2 plus 1 means it would be triplet. It would be triplet. Triplet is Z. So this is Z. Then if you are talking about this one, so the neighboring hydrogens are 3. So 3 plus 1, it would be giving you quadruples. It would be giving you quadruples. So this is the one. This is W. Okay, I would say this is W. Okay, and then this is going to be nothing. No one is present in the neighbor of this one. It's gonna give you singlet. Singlet. There is no neighbor of these three hydrogens. So this is singlet. So I can say that this is the taller singlet. This is the weaker, like the smaller singlet. So it depends upon the number of hydrogens. So that would be like W. And oh my God, where is this? Yeah. So this is W and this would be Y. This is Y and this is W. Because Y has a higher, you can say, mass. It's more stable one. It's more stable one. Okay, so that's why. Explain the splitting pattern of the peaks at 4.2 and 1.3. Of course, 4.2 at 4.2 at 4.2. This is quadruple, quartet. So why I'm getting quartet? Because the neighboring hydrogens are 3. So I'm applying the relation n plus 1 rule. N plus 1 rule. So that's why I got at 4.2 ppm quartet, quartet. And then what they are saying, what they are saying in 1.3 ppm. So at 1.3 ppm, I'm getting triplet. I'm getting triplet. So means that for sure there would be like some other elements as well, of course, because we have to see the neighbor. If the neighbors are one, so that carbon would be giving you doublet n plus one. And if the neighbors are three, so 3 plus 1. If the neighbors are 4, so 4 plus 1, that would be the multiplet. That would be the multiplet. So what am I supposed to write in this one? So you would be explaining like how many neighboring hydrogens we have, and then you have to apply the n plus 1 rule, and then you can talk about the like whether I would be getting triplet, whether I would be getting quartet, or whether I would be getting like multiplet. Okay, so in words, how am I supposed to write? You can see this at 4.2 ppm. At 4.2 ppm, there is like 4.2 ppm means that it would be a tetrahedral. 4 point there is quartet. Okay, due to three neighbors hydrogen. Okay, on adjacent carbon atom. This is of 2 marks. You have to like state other as well. Okay, this is of 2 marks. That's why. At 1.3 ppm, you can see there is a doublet, triplet. Okay, there is a triplet. Why? Due to two hydrogens. Okay. The carbon 13 NMR spectrum of ethyl 3 oxobutanoate has 6 peaks. Draw the structure of an isomer of ethyl 3 oxobutanoate that contains a carboxylic acid group and a ketone, but only has 4 peaks in its carbon 13 NMR spectrum. NMR spectrum. Oxobutanoate. This is oxobutanoate. This is oxobutanoate. So I have to draw the isomer of this one. Okay, I have to draw the how many carbon atoms we have? 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So I have to make that structure in which we would be having a 4 peak in its carbon 13 NMR spectrum. I would be having only 4 peaks. If you can see that, if you can consider only carbon atom, okay. So I can draw like that. I can draw like that in which I can see the only 4 peaks. So we have ketone group. I can see only one peak. Then we have carboxylic acid group. I can see another peak. I cannot change the functional group, remember. And then then I have to complete the carbon atoms. I have how many carbon atoms we have left? Uh, like 4 carbon atoms, right? So 2 peaks, two more environments I need. So it would be like that. It's one and only possibility, man. If you are thinking something else, do share it with me. I will tell you you are wrong. If you have any idea that we can draw like that, we can draw like this, why didn't you draw in this manner? So, man, there is only one way. It's hit and trial method. First of all, you have to draw, then just count how many different environments it's going to give you. And then you can uh, correct your mistake after drawing frequently. So you can do more and more practice about that. Then it would be it would be better for you. Okay. 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 So